Hello, we are track 2 for ClaimChain, the blockchain-based fintech application. And track 2 is focused on blockchain security. So overall, blockchain is a very secure platform. However, they are prone to specific blockchain attacks. And the one we're looking at here in track 2 is the Sybil attack. And basically what happens in a Sybil attack is an attacker can subvert a blockchain system by creating many user accounts or identities, and that'll overall hurt the integrity of the system. So the big problem is that attacker nodes in a blockchain, when the Sybil attack is occurring, they could outnumber so-called real nodes, and that could have an extreme influence over the system and harm the security of our software, which is an insurance claim industry. So the consequences is fraudulent users could access transaction data, and that will result in Sybil attack, of course, and it causes a loss of integrity and a harm in the reputation of the system. And reputation is very, very important in a blockchain system, and transaction trustworthiness is paramount. And if you look at the diagram here, we can show that the communication there is sort of between good nodes or normal nodes is there's a middleman with a Sybil node, which that can cause a lot of issues. And so here is a outline of our solution approach. And so what happens is the user will file a claim, and that will get put into Hyperledger Composer. And basically, if that user is described as suspicious, what will happen is we will look at do some anomaly detection. First, there will be a CloudWatch alarm triggered, and then we'll do anomaly detection, wherein we'll use a machine learning model to check to see and detect whether or not it's fraudulent. And if they are, we will have a defense by pretense mechanism. So we'll redirect the user to a different page so they really won't know that they're being defended against. And of course, the transaction will get rejected.
So as you can see, this is our application. The insurance claim form, we have like separate labels, like separate forms which we take input from the users. We take input like name, issue, and balance, and number of claim years, location, and driver's ID. And when we run ng build prod, what it does is it creates an application which we can use to deploy in S3, and then we can generate a public URL. From that public URL, anyone can access our application. So currently it is running a production application, as you can see now. Once it is done, it creates a dist folder. In that folder, we will have some files like index.html and images, background images, everything. As you can see on the left, a dist file is created. In that dist folder, you will have the index.html is the main part where our form is present. And then we take this, and then we host this and upload these dist folders in this S3 bucket. As you can see, index.html and everything. This is our this is where our application is uploaded in S3. And then suppose when we go and check in the properties, this will be our public URL. And when we click this public URL, we go to our application. This is our form. When any user tries to log into our system, he has to register first. And suppose the user is registered, he can log into our system. And when he enters into our system, he can do some things like he can send like details of his insurance form. Suppose I will give some details like name, and the issue is car accident, and the policy number is something, and the claim is 1 year, and location which the accident take place is Colombia, and the driver's license and the date of the incident. And if we click on check details, as you can see, the URL changes. This is the mechanism where our load balancer comes into play, and I will explain this in the next part. And the data which we inputted here goes to the Hyperledger. And if we want to see the data which was inputted by us, this is the user part where our whole information gets stored. When we click on user, and then when we click on try it out, we will see the details of the form details which were inputted by the users. Suppose these are some of the details entered by some users in the system. And these details will be stored in this hyperledger, and from this hyperledger, this data will be stored into an S3 bucket in CSV, and this will be explained later by Mike.
Okay, so I'll be describing an attack simulation experiment, and basically it's showing that what the consequence of a simple attack is. So here in the insurance claim, if you post your data, you can be able to see the hyperledger data in the admin table. If we get the data here, we'll show basically the consequence of an attack. So right here, we have a table in the direct order of the claim submission. So it's one here, then another's. But what happens here is we see 1 and 3 are identical, also 2 and 4 are identical. But what happens here is the priority order gets shifted. So even though this one was submitted second, it actually can go third in a way, because the resubmission of fraudulent claims will affect the priority. I also have another one showing it here. It's in the same vein. Basically, the first one and the third one are the same, and they'll get processed first, which is an issue. And so then moving on to some of the S3 stuff that we used for the machine learning, we have a data set here hosted in S3 bucket, and to show it here, we have username, driver's ID, date, policy number, location, issue, and then a fraud classifier. So if we look here, we have a fraud one here and a fraud one there. They both have the same driver's ID, so that's how we know, and that is used for the machine learning models that I will explain later.
So earlier I explained the redirection part. So this is how it works. When any malicious user enters our system, it will go through the load balancer first. This is the load balancer, and then we have written some scripts in Lambda. What it does is it will get the details from the S3 bucket, the details of the user who has entered our system, and then it will check whether the user is malicious or not. And then if the user is malicious, it redirects them out of our system to some other URL. Suppose if he is the normal user, he stays in our system. And as you can see, these are the graphs generated by CloudWatch. Suppose if any malicious user enters, this will be invocated. It shows us that how many times it's invocated and the duration of invocation under error and success counts. As you can see here, this is the load balancer, the claim redirect, and this is the SNS part. This SNS part I will explain later. Now Mike will explain the defense part.
Okay, so for the anomaly detection, we need to use machine learning models. So we picked 4 machine learning models that I will describe in a moment. But first, we hosted the machine learning models in Amazon SageMaker, and I have a notebook instance here. So if we open up Jupyter Notebook, what it'll show is I'll have these 4 machine learning models. So we have k-nearest neighbors here. We have logistic regression here. We have support vector machine, and we have decision tree. So just to run you through one of them, if we run it, what it'll do is it'll first get the data from the bucket up here, and then split it up into test and training data, 70-30 split. And what it'll do is then we'll get the values. So here we see here the accuracy values. Then we can also grab the true negatives, false positives, false negatives, and true positives. And so we end up getting a accuracy value, but also precision, recall, and then just an overall F-score. And so what we noticed is that overall support vector machine and logistic regression appear to have the best testing accuracy of about 80%. And while decision tree had one of about 70%, so it's definitely the worst one. So the best models that we used were logistic regression and support vector machine.
So as you can see earlier, as I have given a malicious ID for you to view how our load balancer works. This is the malicious ID, and when I click the details part, it actually redirects to Google. As you can see, the URL changed in a moment. So this is how our Lambda function works. The Lambda function takes in the data from the S3 bucket, and then it checks whether the user is malicious or not. And then if the user is malicious, go to google.com, and then if the user is not malicious, it enters into our system, and it triggers a notification showing the malicious user's details. So we here collect the malicious user records, and then we dump that records into a JSON format, and then this JSON format is sent us in the form of an email, as you can see. These are all the malicious users present in our, like, malicious users with the same ID as that of this, and this ID, as we have entered here, this ID also goes into our system, and then the system alerts us saying that this is the malicious user and take any action on them. And these are the topics to which the SNS notifications will trigger. Currently, it is showing to my email. These users will receive the notification part along with the details of this. And this is the whole, like, project, how we are applying defense pretense mechanism. And then so to conclude this part, we can say that ClaimChain could effectively block potential Sybil attackers while keeping the legit users in safe positions. And this will also, our system will also provide different types of attacks on ClaimChain system. And for now, our system, we are only working on this insurance applications part, and in future, like, we can also expand this part to some other applications as well. And in our future works, we would like to generalize the system based on the behavior of Sybil attacks. And we are trying to convert the behavior of Sybil attack by mathematically modeling them into a system, and then creating a system which works on statistical parts. And then we analyze unique design principles for the system, and then investigate the mechanisms which will help in not only eliminating Sybil attack and also other types of attacks. And in this way, we can use our application to devise mechanism to detect and mitigate Sybil attacks, and not only Sybil attacks, but many kinds of other attacks also. Yeah, thank you for giving this opportunity. And we will be concluding here.